You can use graphs to solve rate problems involving two variables. But before we do that, we need to make sure we know how to draw the graphs. There is a standard convention for scatterplots, which is the same across mathematics and science. The independent variable goes on the horizontal axis, across the bottom, and the dependent variable goes on the vertical axis, down the side. If you're going to get your gradient correct and interpret your answer the right way, you have to remember this convention. So let's have a go. Chloe earns $15 per hour. For 2 hours work, she earns $30. For 4 hours, $60, and so on. Draw this information on a graph and use the graph to determine how much Chloe would earn for 5 hours and how long Chloe would have to work to earn $140. Well, first let's draw the graph. Now remember our convention. The independent variable goes horizontally and the dependent variable goes vertically. What are our two variables here? Time and pay. Which one depends on which? Try putting them in a sentence. Does the length of time Chloe works depend on how much pay she's given? Or does the amount of her pay depend on how long she works? Obviously the second way. The pay depends on the time. So the pay goes vertically and the time goes horizontally. Alright, plot the points on the graph. Do this carefully and accurately. You should get them lining up in a straight line, since this is a proportional relationship. Now draw in a line that connects up all the points. It should be a single straight line, not a join the dots that bends up and down. If any of your points don't lie on this one straight line, you've made a mistake. Okay, now I can use this graph to answer the other questions. How much would Chloe earn for 5 hours work? Draw a line up from 5 hours to the line on the graph, then across from there to the number of dollars. Chloe will be paid $75 for 5 hours. How long would Chloe have to work to earn $140? Draw a line across from $140, then down from the line on the graph to the number of hours. That looks like 9 1/3. 9 hours and 20 minutes. Alright, now we've drawn this graph, let me ask you another question. What's its gradient? What's the gradient of this graph? Do you remember how to calculate the gradient? The gradient of a graph is the rise over the run. Gradient equals rise over run. So what you do is you pick any 2 points on the graph and you work out how far the graph rises over that section between those 2 points and how far it runs over that same section. Here it rises from $30 to $120, which is a rise of $90. And it runs from 2 hours across to 8 hours, a run of 6 hours. So the gradient, which is rise over run, is $90 over 6 hours, which is $15 per hour. Hang on a minute, $15 per hour was the pay rate I started with. Isn't that interesting? The gradient of the graph is the same as the rate in the question. That's important, remember that. The gradient of the graph is the rate. Let me show you another example. A seedling is measured as it grows. After 3 days, it's 10 centimetres high. After 6 days, it's 13 centimetres. After 9 days, 16 centimetres. And after 12 days, it's 19 centimetres. We're going to draw a graph and use it to make some estimates. And then we're going to calculate the gradient and work out how tall the seedling was when it was planted. So let's begin. Draw this information on a graph. We're going to need to know which variable depends on which. Try putting them in a sentence. Does the age of the seedling depend on its height? Or does its height depend on how old it is? The height depends on the age. So put the height on the vertical axis and the age on the horizontal. Notice the axes go a bit further than the maximum data values, because I know I'm going to have to answer a question about when the seedling is 25 centimeters high. Next, carefully plot the points. Did I actually need all 4 points? What's the minimum number of points I need? Then draw a line through the points, a single straight line using a ruler. Make sure it goes through all your data points. If it doesn't, you've made a mistake. Now we can answer the questions. Estimate the seedling's height after 5 days. Draw a line up from 5 days to the line on the graph, then across to the other axis. 12 centimeters. The seedling will be 12 centimeters tall after 5 days. And estimate how long it will be until the seedling is 25 centimeters tall. Draw a line across from 25 centimeters, then down from the line to the age axis, 18 days. It will take 18 days for the seedling to grow to 25 centimeters, assuming it keeps growing at the same rate, of course. Speaking of rate, let's calculate the gradient of this graph. Gradient equals rise over run. So we need to pick 2 points on the line. You can choose any 2 points. They don't have to be your original data points. In this case, I've chosen 2 points where the grid lines intersect, so I can read off the values more easily. The rise over this section of the graph is from 10 to 20, so the rise is 10 centimeters. The run is from 3 to 13, 10 days. So the gradient, which is rise over run, is 10 centimeters over 10 days, which is 1 centimeter per day. Can you see what the gradient represents in the original problem? 1 centimeter per day. It's the rate of growth of the seedling. How tall was the seedling when it was planted? Well, where is that on the graph? How old was the seedling when it was planted? 0 days old. So where is my line at 0 days? It's here, at a height of 7 centimeters. The seedling was 7 centimeters after 0 days, which is to say when it was planted. This point on the graph is called the Y-intercept. It's where the line on my graph intersects the y-axis, the Y-intercept. The gradient of the graph is the rate. The Y-intercept is the initial height. Notice that this graph doesn't go through the origin. If it did, that would mean the initial height of the seedling was 0 centimeters. But in this case, the initial height was not 0, so the line on the graph doesn't go through the origin. Not all linear graphs go through the origin. Actually, I can write this relationship another way too. I can write an equation. Look at these numbers. In every case, the height of the seedling is 7 more than the age. The height is just the age plus 7. And what's 7? It's the Y-intercept. In fact, the gradient is also hiding in this equation. It's just that its value is 1 in this case. The height is 1 times the age plus 7. The dependent variable is equal to the gradient times the independent variable plus the Y-intercept. This equation structure applies any time you have a linear relationship. We'll see it again and again as we look at more complex examples.